In this lesson, you will learn to identify the corresponding parts of congruent figures. Now, prior to this lesson, you have already learned that congruent shapes are shapes that have the same size and same shape. So here we see two triangles that are congruent. They're the same size and the same shape. Now, with congruent shapes, and in this case congruent triangles, we have different parts of the shape that correspond to each other. So let me explain here what this table is showing. This table shows that point A, or the vertex A, corresponds with the vertex D for the other triangle. So that's what we have here. A corresponds with D. The B corresponds with the E, and the C corresponds with the F. And that makes sense because A is on the top of the triangle, and D is on the top as well. B is the bottom left, E is also the bottom left, C is bottom right, and F is bottom right. So those are what we call corresponding vertices. Now, along the same lines, we have corresponding angles and corresponding sides. The corresponding angles would be angle A and D, the top angle, and the right angle down here in the bottom, angle B and angle E, would be corresponding. And then angle C and F would also be corresponding. Those are both on the bottom right. We also have corresponding sides. The left side, AB, and left side, DE, would be corresponding. And then the bottom, BC and EF, would also be corresponding. And then AC and DF are corresponding. So that is what we see here in this table. So based off this information, we can conclude that if we have congruent triangles, then the corresponding angles are congruent and the corresponding sides are congruent. Meaning that the corresponding angles have the same measure. So if angle A is, let's say, 30 degrees, then angle D, the corresponding angle, must also be 30 degrees. And when dealing with sides, let's say AB were 10 inches, then DE must also be 10 inches if they are congruent. So the corresponding angles and sides are going to be congruent. So our definition of congruent triangles are two triangles are congruent if and only if their vertices can be matched up so that the corresponding parts of the triangles are congruent. And this goes with any shape, not just triangles. It could be quadrilateral, pentagon, etc., where two shapes are congruent if and only if their vertices are matched up so the corresponding parts are congruent. Therefore, we can say, based off this definition, that the corresponding parts of the congruent triangles are congruent. And we're going to use this phrase a lot, so instead of writing this out every time, you will see the letters CPCTC standing for the corresponding parts of congruent triangles are congruent. So that's a shorthand way of writing that whole phrase. Now, looking specifically at triangles for a minute. Here if we have two triangles, and we're trying to write the fact that they are congruent. Well, what I need to do to show that two triangles are congruent, or to write it, we need to make sure that the corresponding vertices are in the same location when I write. What I mean by that is if we were to say that triangle BAC is congruent to the other triangle, I need to make sure that the letters are matched up. So if I have letter B coming first when I write triangle BAC, then the corresponding vertex must also come first for the other triangle. So the corresponding vertex for the other triangle is E, so E must also come first for this other triangle when I write it. And then I use the letter A next. So here is A, and A is on the top of the triangle, and the corresponding vertex for point A would be point D. So because A comes second when I write triangle BAC, I need to write the letter D second for triangle EDF, because those are corresponding vertices. And then point C corresponds with point F, so because point C comes third, point F must also come third. Now the order does not make a difference necessarily, other than the fact that make sure that the other triangle is matched up appropriately. So I could write this in the following ways, where C corresponds with F, the B corresponds with E, and A corresponds with D. So this one is okay. And the other ones as well, as long as the corresponding parts are in the same order, then I can write it in any of these 6 different ways. Now here is another set of triangles that are still congruent, but what we have is the triangles are rotated. So the left side does not correspond with the left side of this triangle, but instead the left side corresponds with the right side over here. So what we're trying to do is we're trying to write that these 2 triangles are congruent. But the question is, how do we do this in a way where the vertices, the corresponding vertices, are paired up? So the way to do this, we look and we see that A is between the sides that are 4 inches and 6.5 inches. So in the other triangle, we try to find which vertex is between the 4-inch and 6.5 inch side, which would be the Y over here. That's between 4 and 6.5 inches. Next we look at B. B is between the 4-inch side and the 7-inch side. Over here we see that Z also is with that same situation in between the 4 and 7-inch sides. And then by default, the C has to correspond with the X. So when you write this, if we write triangle ABC is congruent to this other triangle, just make sure that the corresponding vertices are paired up. So A is paired up with Y. A comes first in this triangle, so we have to write Y first over here. The B corresponds with Z. The B came second, so the Z comes second over here. And then the C corresponds with X. C came third, so X comes third over here. So when you write that these triangles are congruent, you would write this as triangle ABC is congruent to triangle YZX. And there are different ways you could write this, as long as the corresponding vertices are in the same order. Now, using the same picture, what we want to do is not only show which vertices are paired up, but also show which side lengths are paired up and which angles are paired up. So here, the side lengths are pretty easy because we can tell by the lengths which sides go together. This 4-inch side goes with this 4-inch side. The 6.5-inch side goes with this 6.5-inch side. And the 7-inch side goes with this 7-inch side over here. So when you draw this, you can put the lines through it to show that those particular sides are congruent. So the sides with 1 line through it are congruent, the sides with 2 lines are congruent, and the sides with 3 lines through it are also congruent. So right here, side AB corresponds with side YZ. So AB is congruent to YZ. And then BC down here is congruent to XZ, or ZX up here. So those are congruent. And then lastly, AC corresponds with XY. So AC is congruent to XY, or YX, same thing. So that is the side measures. Those are the ones that are congruent. Next we have the angles. So as we said, A corresponds with Y. So that angle up here corresponds with this angle down here. So the angle can be named as angle BAC, and the other angle is going to be XYZ. And those ones are congruent. And then the B corresponds with the Z up here. So that angle is going to be congruent to this angle up here. So the way we name this, we have angle ABC. ABC is congruent to this angle up here, which would be XZY. And then lastly, angle C is congruent to this angle right here, angle X. And using 3 letters to name it, we have angle BCA. So angle BCA is congruent to angle, and that would be ZXY. So those are the corresponding angles, and those are going to be all congruent. The arcs are congruent. Then lastly, looking at this picture, we still have congruent polygons, and the same rules apply as do with triangles, where when I want to name this, what I do is I pick a point to start at. So with one triangle, let's say I start at the letter A. So starting here at A, I'll write the letter A, and then I'll write the letter B, and then C, D, E, F, G, and H. So once I start going in the clockwise direction, I continue going clockwise until I get all the way to the end. So I would say polygon A, B, C, D, E, F, G, H. So that's a really long name for a polygon, but we need all of the vertices when naming polygons. And then that's congruent to this other polygon, and the A corresponds with the S, the B corresponds with the T, the C corresponds with the U, etc. So when I name the other polygon, I start at S and do the same thing, go to T, then to U, V, W, X, Y, and Z. So we have these two polygons are congruent. So once again, when naming polygons, pick a letter to choose from or start from, and then I'm going to go either clockwise or counterclockwise. But I cannot jump around and say polygon A, B, then G, then E, then D. I can't jump around like that. So once I pick a letter to start from, go either clockwise or counterclockwise until I reach the last vertex. And then if they are congruent, make sure that the corresponding vertices are in the same order for both polygons. That concludes our lesson for today. We will see you next time.